Okay, so in this video, we're going to talk about vector embeddings. So first, we will know why vector embeddings have been invented in the first place. Like, what was the reason? See, machines think data in terms of zeros and ones. When you say machine, what you understand by king? The machine will say, yeah, the king is like stored in a memory in terms of zeros and ones. They will not understand king as we understand king. And when you say machine, do you know the relation between a king and general? So machine will say, no, I don't know anything if you don't tell machine. But we know it, right? We know it. So if we want our machine to become AGI, to become like us, so machine should be able to perceive data like us. So first of all, how we perceive data, how you say that that man is a king or that man or woman is general. If that man has a certain features like man is ambitious, brave, wearing clothes, has an army and everything, that man is a king. Now, how you say that man or woman is general? Certainly, the 0.8%, 0.8 probability is there, right? That general will be a man. Man is less ambitious, less ambitious. So we can say that's why he's general because he is stronger than king but less ambitious, and he's also more brave than king. That's why he's the general of the army. So, how I perceive this, I look at something, I see that there are some features in it. Okay, so that's the thing. So, we analyze features. If something that has certain features, that thing is that thing. So, machine should terms data in terms of features. Like, if we tell of if machines can learn this representation, like a king is 1 in man, ambitious 0.7, brave 0.8, and general is 0.8, 0.5, 0.9. If machines can learn this representation of data, and what is the purpose of this and how it can help machines? Because are you not noticing that these two are kind of similar? Just 2 plus point 0.1 minus point 0.2 is there. So, say if machines could learn this, then what will happen? Machines could also learn the relationship between words. That's the main point here. So, because we humans also know about individual words and also know about relationship between words, because same sentence can mean a different thing altogether if we rearrange the words, right? So machines can also know the similarity between words, how words relate, and how words are individually being featured. So eventually machines can become AGI. That's my point here. That's why machines should learn this representation of data, not zeros and ones. So let's move ahead. So the question now is, how do machines learn this stuff? So first of all, machines will not learn this, and machines will still think in terms of zeros and ones. But what we will change how we provide input to the machine. So when we say machine, hey machine, king. So thing is, we will not say word king to machine. We will say this array. So this representation, we will say king in terms of 1, 0.8, 0.9. So what we have to do? We have to create encodings. We have to encode king to this. So how we will generate these encodings? We will take help of machine learning, neural networks, transformers, encoders. So, how the process will happen, I will explain it in very simple manner. See, what we will do, we have to generate encoding, right? So first a human will generate this. Human will generate this from his mind, and then what we will do, we will tell machine learning algorithm to predict 0, 0, 0 and key for king. Like we will say to machine, hey machine, here is a arrow of 0, 0, 0, and here is a word king, and predict what king will look like. It will look like 0.1, 0.8, 0.7, or it will look like 1, 0.8, 0.9. So every time machine predict some random number. So every time we will tell machine, no, no, that's not right. Predict again. So and eventually machine will predict this. So we will perform error learning, what we say. So we will use transformers, encoders. We all know about transformers. If you haven't learned about transformers, then what are you doing? So please learn about transformers for a good career, for a good job. So what we did here, we converted words to vectors. Eventually, king is a word, and we have make its vector. We have founded its vector. We will do for every word, for king, for man, for dog, for woman, for every word we will create it vector. How vector of a man will look like, how vector of a king will look like. So if two vectors are similar, like a vector of a son and a dad will be close to each other. A vector of a son and daughter will be close to each other, but a vector of crocodile and lion, it will be far away from each other. And vector of a living things and non-living things will be also far away from each other. So we will create vectors in a way so that similarity can be captured between words, relation can be captured between words. And how we will do that? First we will from our understanding we will create this, and then we will use machines to learn this. So you can be asking, if we can create this, why we need a machine to learn to create this? Like it is being created by us in the first place. So the answer is, when you type in ChatGPT, what is this formula? What is that formula? What is the use of this? What is the use of that? So the thing is, we can't create embeddings for everything. By humans, humans can't create encodings for everything, but machines can create if they learn how to create. That's why we are making machines to learn, create these vectors. So using machine learning, using neural networks, machines will learn how to create these vectors, and then machines will itself utilize these vectors to learn relationship between. So they can understand human language. So that's how machines learn this. That's how machines use this. So now let's talk more. See, I know you have been noticing that these points can be coordinates like 1, 0.8, 0.7 can be plotted in three dimensions like this, right? Can be plotted. So how the machines are finding similarity is so simple. Like if the angle between the lines connecting these points to origin, this is point corresponding to king, this is point corresponding to general, this is point corresponding to dog. If the angles between lines are less, so they are similar. Machines are interpreting similarity this way. So you can see that a man can be converted into vectors like this woman, this king, this queen, this, and you can see like how they are plotted in 2D space of, or say high dimensional space. So you can literally see like we are deciding features on what features machine should judge. Like we have decided that machine should judge on the feature of living being, feline, human, gender, loyalty, work, plural. So this is how it's working. So now let's understand how machines interpret sentences. So I know you're seeing this picture and this picture is not quite visible. So let me make it visible for you. So let's make it big. I hope this is visible. I hope this is visible now. So let's see. It is a very classic example now. So how can machine misinterpret sentences? So let's see. I say two words sentences, right? Hot woman, hot dog. The meaning of hot is different in both contexts. I don't know why I came up with this example, but yeah, you understand that meaning of hot is really different in both contexts. But the individual meaning of hot doesn't change. But the way it is used in the sentence, it changes. It is quite funny, right? So how do machines learn this? The human language is this, what we can do. So, so what do machines do? They first create individual embeddings like this, like this, like this, like this. Then what they do, like for sentences, they do extra thing. They look on they look around words. For creating the embedding of hot, really for that sentence, they will look what are the other words that are this word is used. Hot is used with woman, hot is used with dog, hot is used with chicken, hot is used with summer. So the embedding of hot that machine will create will be different in four sentences, like hot dog, hot chicken, hot summer. So that's how machines interpret sentences. Like really, first they do predict individual embeddings, then they change embeddings according to the surrounding words. So they do prioritize surrounding words. So if they don't, then machines will really hallucinate. They will never understand human language. So see, hot dog, hot women, the meaning of hot is different now. That's how we humans evolved to this point. We could have find different words, but we let it go. We let our humor understand it. So machines should also understand our humor. So we are going to the end. We are coming closer to the end of the video. So let's go. So this is our object one, word one, word two, word. So this is a sentence. Embedding model will create vectors, and these vectors will get also updated because from the surrounding vectors, so that it captures the meaning of sentence, not individual words. So you can see that this is a very happy person. That is a very happy person. That is a happy dog. These vectors are closer. And today is a sunny day. It is quite far away from these. How machine will measure similarity? this angle. Angle is important, not length. Angle. I repeat, not length. Angle, because machines use cosine similarity algorithm. So you have been wondering if only sentences can be embedded as vectors. No, PDFs, images, videos can also be embedded using vectors. So nowadays, our recommendation algorithms in Insta, YouTube, Spotify are getting better. How they are getting better? Because they are converting videos and these all things into this vector kind of stuff, and from that they are easily able to find similarity like this. So from that similarity, they are able to like recommend what we should watch next. That's how these recommendation algorithms are keep getting powerful and powerful, just because this vector embedding. So we are using vector embeddings in our daily life so much because we are using AI, and AI uses this. That's a learning about vector embeddings is so much of importance. So I hope you have learned this throughout the video, and you can also comment like what are the points that I missed and what are the points that you liked also. So, goodbye.